Hi, my name is Uinso, and today I'll be explaining the third assignment of my computer system design class. So this is my ARM assembly code. It tries to continuously light up certain LED in the Zedboard sequentially, so from LED 0 to LED 7 and back to 0 again. So we start in the main. The first instruction, we load the base address of LED in register R4, which we define up in here, so 41200000, and we initialize register R1 as value 1 and R5 as value 18 hexadecimal. So R1 will be used to store the value that lights up certain LED in the Zedboard, and R5 will be used to check whether the value of R1 is equal to the maximum value of the LED, which is LED 7. So if it's equal to LED 7, we just want to loop back to LED 0. So inside the loop, we have this instruction. So we try to store the R1 or the value of LED inside the data register of the base address of LED. So initially R1 is 1, so we store 1 in R4. So the first LED 0 will light up. In the next instruction, we have branch. We branch to the CSD main, which is the C code that I made. So this certain C code dictates the delay or interval that takes before we switch to the next LED. So from LED 0 to LED 1, we want to have a certain interval depending on which switch is activated. So we store the base address of switch in SW, which is 41210000, and we store the data inside that address in this data variable, and we made a variable count so that we know the delay that we want. So I used a switch case function here. So depending on the data, we want to know how big the count is. So if data is 1 or the first switch is activated, the delay is 800 milliseconds. Or if the data is 2 or the second switch is activated, it's 700. So same for the ones below, 600, 500, 400, 300, 200, and 100. By default, the delay is 1 second, so either no switch is activated or multiple switches are activated, the delay is 1 second. So we initialize the value of count as this, depending on the switches. And I used a for loop, so it will count from 0 to this count. And we return to the ARM assembly. And in here, we compare the value of R1 and R5. So R1 is the current value of LED activated right now, or lit up right now. And R5 is the last LED, LED 7. So if R1 or the current LED is equal to LED 7, we want to loop back to LED 0. So we just branch equal to main, and we reset the value of R1 to 1 so that it lights up LED 0 in the next loop. If not, we want to update the value of R1 so that we shift to the left by ones, so it multiplies the value of R1 by 2, so that it will always light up the next LED. And we just branch back up the loop again, and we continuously do this sequentially. And the only thing that will be different is depending on the switch, the interval will be different. By default, it's 1 second. Switch 1, 800 milliseconds. It gets faster. Switch 2, 700, a little bit faster. And let's see, switch 6, yeah, way faster. This is 200 milliseconds. And switch 7 is 100 milliseconds, really fast. So if we light up let's say 2 switch, by default it's 1 second again, and when you go back to no switch, it's 1 second again.